All right, so here I'm giving you the information in a little bit of a different way. I'm just giving you the line and the A and the epsilon. Okay, so let's just draw the line. So you know this is a line that looks something like this, right? And A is 2, so here A would be 2, and that goes with the Y value of, you just plug it in, right? That gives you the Y value of 6. Okay. So what this epsilon is, remember, it's an epsilon neighborhood. You move up by 0.1 and down by 0.1. So this would give me 5.9, I'm sorry, this one would give you 6.1, and this one would give you 5.9 down here, right? So these are the two x values. And then I would work them backwards, Hey, wait a minute, what's going to happen here? And I want you to notice, because it's a line, don't you know that these two distances will be exactly the same? Other times I had curvy functions, right? But now since I have a line, my picture doesn't quite show it, but they really are, this distance will be exactly the same as this distance. Okay, so since it's like that, we're going to do something different. So we're not going to give you an epsilon for a number. So when we have a line, you'll be asked to prove using the delta epsilon definition. So what you're going to do is you're going to say, okay, give me any epsilon, I'll tell you what the delta has to be. So these are the words you would have to write. Yes, you have to memorize these words. We don't have to write the algebraically thing, but you need to write. Okay, we must show that for any epsilon bigger than 0, there is a delta bigger than 0 such that if, this means x's are in the delta range, then this means y's are in the epsilon range, and we're leaving it in general for the epsilon. And you don't have to write this. This is my work to say this is what we're going to do. But you need to write this. You need to write this because you're making a mathematical argument. So you're writing out what I'm going to do. Okay, so after you write those words, just like before, we start with the y-axis and with the epsilon. So let's just write this down again. So this is going to give me 3x, and I'm just going to simplify in here. I'll get minus 6 is less than epsilon. So just like before, I worked the y-axis back to the x-axis. So what I'd like to do is to get to x minus 2 in here. Oh, that's not hard to do. Factor out of 3. Oops, I meant 2 here. Factor out of 3. And then let's divide through by 3. Well, there it is. So here I have that x minus 2 has to be less than delta. Here I have x minus 2 has got to be less than epsilon over 3. So I've worked backwards, and I can now say that delta can equal epsilon over 3, because if I just compare these two, correct? So what I've done, again, let's just get the picture going, right? So I've worked backwards, and I found out that I can go epsilon over 3 in either direction from my A of 2, right? I can go epsilon over 3 in this direction, or I can go epsilon over 3 in this direction. That's my delta, right? Think about it. Couldn't I choose something smaller? Couldn't I choose epsilon over 10 in either direction? Yep, I could. If I chose epsilon over 10, something smaller than epsilon over 3, then for sure I end up in my epsilon range. So for that reason, I'm going to add to this and say not only can delta equal epsilon over 3, I can make it less than anything smaller than or equal to epsilon over 3. Okay, so this was one with all the work, and let's just go through one without all the extras, and that we have practice writing it out. So as soon as you see it's a line, you'll see prove, you'll see delta epsilon definition of a limit, no epsilon given, then you're just going to start writing the words. We must show that for any epsilon bigger than 0, there is a delta bigger than 0, such that if, okay, so I'm talking about the x-axis now, so it's got to be bigger than 0, so it's x and then minus my a. Oh, that's kind of tricky, so it's got to be plus 4 is less than delta. So this is my x minus a is less than delta. Then f of x, which is the line, subtract L, which is 11, is less than epsilon, period. Okay, so I work this statement to make it look like this. So I'm just going to fix this in here, so I get negative 2x minus 8 is less than epsilon. So I'm going to be careful here, so put a big star by this. I'm going to factor out a negative 2, so I get x plus 4. So when I'm factoring out a negative 2 in the absolute value, that just turns into a positive 2. Good thing, because my deltas and epsilons are positive numbers. So I'm going to divide through by 2. There it is. So I've got this matching this. So now I can say, therefore, choose delta to be equal to epsilon over 2 or anything smaller than it. So for those of you who are inclined to circle your answer, you would be circling all of this. Kind of ridiculous, so you can skip that part.